Welcome to Conceptual Cambridge. Today we will be going over the topic of functions. Here is everything that we will cover. So let's begin with what are functions. You can think of functions as a machine which takes an input value and provides you with a corresponding output value based on the rules you have provided it with. So firstly, let's go over the notation of a function. So as you can see here, it says the notation is f of x, but remember it is not special and you can take any variable. For example, you can also write it as f of y or f of t or anything. It is not special. So now let me show you what it looks like. Generally, as you can see here, this is the picture. So it is taking an input of 5 and adding 10 to it and providing you with a corresponding output value of 15. So you can think of it as a calculator where you are putting an input value and also providing it with the rule of adding 10 or anything else, then it will provide you with the output. So now let's take another example of it. Let's say we have something like the number of bacteria in an experiment increasing with time. So let me draw a graph of that. So let's take the number of bacteria on the y-axis, number of bacteria, sorry for the handwriting, and time on the x-axis. Let's say they linearly increase, something like this. So now we have a graph. Functions will help us analyze the relationships between the two variables. So let's say that there are 2 bacteria at 1 second. At 1 second, there are 2 bacteria. So now as you can see, we can call it as a function, number of bacteria as a function of time. So for example, what we are doing is f of t can be taken as number of bacteria, and then we can make something like this t. So what you can see is that we have taken an input value of 1 and added 1 to it. So what is happening is t plus 1. This is your function of time, or f of t, which describes the number of bacteria. So this is used typically in the field of engineering. So basically, using these functions, what you can say is that you can predict the future. For example, let's say at time 5 seconds, we need to know the number of bacteria. We already know the rule is t plus 1. So for predicting the number of bacteria at that time, what we are going to do is just input it into t plus 1. So at 5 seconds, it will be 5 plus 1, which is equivalent to 6. This gives you the number of bacteria at the time, which is 5 seconds. So this is how it can help predict the future. So now let's move on. So here we have the domain and range. So first let's discuss the domain. The domain is just the set of input values for a function. For example, as you can see here, we have the input values from 5 to 8. So what we can say is that x is greater than 4 and x is less than 9, or else you can also write this as x is greater than equal to 5, x is less than equal to 8. And for the range, they're just the output values for a function. So as you can see here, we have 15 to 18 values, which are the range for this. So what I can say is that y is greater than 14 and y is less than 19. And same thing, we can also write it as y is greater than equal to 15, y is less than equal to 18. Remember, you can replace the y with f of x. It doesn't really matter which thing you use, the answers will be the same. So now let's move on. So as you can see here, we have two types of functions. So let's discuss the one-to-one function first. So what it does is it takes one input value and produces one output value, and it has an inverse. We will discuss the inverse later. So first let's see what I mean. So as you can see here, we have 5. This is one input and it directly gives one output. Same with the rest of the values. Now let's check many to one function. So what many to one means is that more than one input can have one output. So basically what I mean is like two x values having the same output. So as you can see here, we have the function f of x is equal to x square. If I input any negative value into it and any positive value with the same coefficient, so for example, if I input -1 and 1, I would have the same output value since they are both being squared. Same with the rest of the values which are in negative and positive but have the same number. So this is what it is. Remember, these are the only two types of function that exist. Other functions such as one to many is not a function, and even many to many is also not a function. So what we can do is take a vertical line test. So for example, let's say we have a graph over here. We have a function like this. So what vertical line does is you can pass a vertical line through this. So what this means is that this is a function, and you can also try this with a curve. So let's say it is a curve like this. Now let me put an input, let me put a vertical line like this. So as you can see, it cuts at one point. So what this means is that this is a function. However, if it cuts at 2 points, it will not be a function. So here we have composite functions. So what are composite functions? They are the combination of two or more functions. So for example, we have here g f of x. We can rewrite this as g bracket f of x inside it and then bracket close. So what this means is that f of x will be done first and then g will act on the result of that f of x, since brackets need to be solved first. So this is what's going to happen. Now let's take an example. So as you can see here, we have two things, f of x and g of x. We have two functions over here. So now let's do g of x for this. When we take the input as x for the function of f of x, we get the output 2x minus 5. So we are going to input 2x minus 5 into the function of g of x. So what this becomes is g 2x minus 5. This is what you are inputting it into. So what this is just essentially 3 into 2x minus 5 minus 1. Opening the bracket gives you 6x minus 16. So this is what it is. So now let's take another example with a different input. So as you can see here, we have two other functions. F of x is equal to x minus 4 square minus 1, and g of x is equal to 2x plus 3 over x minus 2. And we have to find fg4. So what this means is that first we will do take the input of 4 and input it into the function of g of x. So let's do that. So 2 into 4 gives me 8. 8 plus 3 over 4 minus 2. So this is going to give me 11 over 2. This is g of 4. Then I input it into my f of x function. So it will become like this, minus 1. Now when you solve this, this gives you f5 over 4. So now students mostly face problem in the domain and ranges for these composite functions. So we are going to discuss that next. The best way to find the domain and range of a composite function is to solve a question. So here I've taken a question from Cambridge past papers and we are going to solve it. So find an expression for gf of x and state the range of gf. So as I told you before, what we are going to do is input the result of f of x into g. So let's do that. 1 over x square minus 4x plus 3 plus 1. So this is what we have. This gives me 1 over x square minus 4x plus 4. This is the expression. And now what we need to do is find the range of g of x. This is where most students lose their marks. So now let me tell you how to do this. So first of all, what we are going to do is, as you know, we can only use the domain of f of x and then the result of that. So I'm going to draw it like this. So we know the domain for f of x is x greater than 5 as it's given in the question, and they told you the value of c. So x greater than 5. Now let's input 5 first. So let's say I have the input of 5. I'm going to input this into the function of f of x. So let's see, 5 square minus 4 into 5 plus 3, this gives me 8. Now I am going to input 8 into the function of g of x. This will give me 1 over 9. So now from here you can tell this will be one of the value which will be included in the range. And now let's see. So now if I take a value greater than 5, basically for example let's take 6. So 6 square minus 4x plus 3, this will give me 15. And when I input 15 into g of x, this will give me 1 over 16. So from here you can see there is clearly a pattern. As the input keeps increasing, 5, 6, 7, the range will keep decreasing. So what this means is that g f of x, so this will be less than 1 over 9. Since I can only put values after 5, so 6, 7, 8, 9, 10. So this is one of the ranges. And then also, as you can see here, if I input a value, for example, let's say 100, a big value, 100 square minus 4 into 100 plus 3 should give me 9603. And for g of x I have 1 over 9604. So as you can see, even if I keep increasing the values, it will never reach 0. So from here you can conclude that g f of x, let me write it here, g f of x must be greater than 0. It can be 0.0001 or anything like that, but it will never reach 0. So this is how you find the range. You can put it in brackets like this: g f of x is less than 1 over 9 and also it is greater than 0.